All right, so for number one, we have this question. It says, find all the duplicate numbers in an array of size n. In our brute force solution, we take one number and then check it against any other number to see if that number is repeated in the array. The problem with this approach is that when you move on to the second number 5, then you will have to go back and recheck all the other numbers again. When you recheck the numbers, you're essentially going over the array n times. So this will lead to a time complexity of O of n squared, where n is the size of the array. For the space complexity, you'll be left with O of 1 because you're not using any data structures. You're just using two for loops to iterate through the array multiple times. Another approach that we can take is to sort the array first, then check if for any duplicate numbers. When you sort the array, the number is going to be either to your left or to your right. In this way, we reduce the time complexity to O of n log n, which is the time to sort an array. Now for space complexity, it's still O of 1 because you haven't used any data structure. So the approach we're going to be taking is using a hash set. So essentially what we're going to be doing is having a hash set of numbers, and every time you see a number, you add it to the hash set if it's not in the hash set already. So let's go through this once. So you see -2, you add it to the hash set. You see 5, you add it to the hash set. You see -2, again, now you check if it's in the hash set. If it is, you put it for your results. So let's go through 8. Let's put it in the hash set. 6, hash set. 5. Okay, it already has it in the hash set, so that's going to be your result. You see -2, that's going to be your result also. Now, in order to not have duplicates in our result, we're also going to put it into a hash set, and that's going to eliminate all the duplicate numbers. So if you notice, we only went through the array only once. That means that our time complexity is now O of n, but our space complexity is also O of n because we're using that extra hash set. So let's go ahead and write some pseudocode to see if we understand the algorithm. So the first thing we want to do is to go through the array and then find if it's in the hash set. So if the number is in the hash set, then we want to add it to our result. Else, we want to put that number into the hash set. And finally, we can just return that result. Now let's take a look at how this will work in Java. So I have this class set up called duplicates in order to test our solution. We have the same array and just a simple printout just to print out that result. So let's start with making our function. So start public static, and it's going to return a hash set of type integer. We're going to call it find duplicates, and it's going to take in an integer array. Then we want to return a hash set, so let's call that result. Let's initialize it. So the result, and a hash set of type Okay, and we also want to have another hash set of just the numbers that we're going to iterate through the array. So let's call that just HSet, same thing. So as we said before, we want to iterate through the array. Array length. And then if that hash set contains the element we on, then we want to add it to our result. So this is how you check in a hash set if it contains the number. Then we want to add it to that result set. Else, just add it to the normal set that you're putting all the numbers. And that's it. Let's run and see if it works. Hopefully there's no mistakes. Okay, so it compiled fine. And there you go, that's our result. We wanted to see -2 and 5, which are the duplicate numbers in our array. Thank you for watching. Don't forget to subscribe, like, and comment if this video helped you at all.